Hi. Okay, so let's start. So the last lesson we started talking about the most difficult question of speed. So the most difficult question of speed of reaction is basically this graph. So this graph, we have already tried two examples. These two examples of the third on your page 96 of your notes, I believe. So today we shall proceed to try the last two examples, and we are pretty much done with the topic of speed of reaction. After that, we have three more topics to go before we are done with the syllabus. So, okay, in this case, I give you this graph. It's already done. Like A is, they will always give you one graph in the question, in an exam context, for example. Then the remaining ones will be not sketched. You have to sketch according to the changes that they have made. So A is given in this case. Okay, so how would you be able to draw the graph for B? So recall that this kind of question got two parts, right? You have the left hand side and the right hand side. Here. The most important question would be which is excess. After you figure that out, you can figure out, oh, is it the left hand side? Left hand side is what? Oh, how fast the reaction is. That means the only thing you care about there is your 5 factors. The other way around, the green color one is how much you have, whether it's how much gas is collected, or what's the rest left. So that is in terms of mole. So you think solely in terms of mole in that perspective. So technically you've done this before lah. So you can try, maybe you take a minute. You can pause this video and just take a minute to try. Yeah. Okay, pause. A minute has passed. Unpaused. Yeah, so let's take a look. Oh, there is no limiting or excess here because limiting excess is basically when you have at least two reactant lah. In this case, one reactant, what limiting, what excess? That one thing confirm finish on what? So you have to find more lah because you don't know how. When you find the mole, you realize, oh, I started off with 0.06 mole. My new condition 0.05 mole. I have lesser reactant. If I have lesser reactant, how much gas will I have? Well, I'm pretty sure it's not gonna be the same. And it's gonna be less. Then you'll be less how much less Well, technically 5/6 lah. So you will sketch. So the graph will look like this. It will end slightly lower than A. You need to take a ruler and draw and measure that it's 5/6. No need lah. Roughly can already. Then in terms of the 5 factors, the concentration change. 0.2 mole per dm cube concentration becomes 0.5 mole per dm cube concentration. So it's faster. So that's all. That's how you get the mark. Alright, so now we're gonna try the last one here. Again, A is given to you. Can you draw B? So you can pause the video, maybe give yourself a minute, then we try again. Okay, pause. 1 minute passed. Unpause. Okay, let's take a look. In this case, they tell you that the acid is excess. Cool. Then, okay. So, what changes can you see? Seems like there's a lot of changes. But in terms of my mole, my limiting reactant mg, 4 gram to 2 gram. That means my limiting got lesser lah. How much lesser? Half. If my limiting is half, how much gas will I get? Lesser and half. Then in terms of the speed of reaction, you started off with 0.2 mole per dm cube, now becomes 0.1 mole per dm cube. Concentration drop. So it is slower also. That's why the answer is what you can see here. Green. Yeah. Okay, I'll go through if you C. So looking at C, right, you always compare whatever they want you to sketch against what is given by them lah. Huh? Why? I don't want a case whereby you do B, you got B wrong. When you draw C, you C, you compare C against B, which is wrong. You compare, of course, you don't know whether you are wrong or not, right? But that's why if you compare whatever graph you are supposed to sketch against the given graph, you don't likely have an error carry forward. You don't likely have a one wrong lead to another wrong thing. So A and C, it seems like everything is exactly the same. Huh? That means the graph is the same lah. Honestly, you think we are so dumb, meh? We are not a genius in that sense. What we play mind games. The answer is exactly the same as the one given to you. It's very unlikely to be that case lah. That's a bit too much. That's ridiculous. Definitely got some change. So you need to figure out what's the change. So from your eyes, you can see that the acid changed. What kind of change ah? HCl is a strong acid. Okay. H2SO4 also a strong acid. Okay. How do you know they are strong acids? Remember there are 3 acids you are supposed to know. HCl, H2SO4, HNO3. You know them from the topic of acid, bases and salt. Oh, HCl is monobasic. H2SO4 is dibasic. Cool. So basically something changed in terms of excess. Think about it. Excess, something about excess change. Will I have the same gas produced, more gas produced, or less gas produced if something about my excess change? Ding, 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 ding. Same lah. Already say you are excess ready what? Your excess become more. Who cares? Still excess. Excess become less. Who cares? Still excess. So anything that changes your excess, you still get the same gas. So you still end at the same place. But yeah, that's it. So you still end at the same height, but it is faster. Huh? How I know? So I show you here. So when remember I say that the graph question is the toughest. The toughest of the toughest is this when they include dibasic, monobasic, strong, weak acid. Oh my god. That is the hardest ever we can think of. I cannot think of anything worse than this. This is like worst combination. Because in order to make sure you get it correct, you probably need to write some equation to help you see. So I write down the 2 equations for both acids. Then I look at it and go like, okay, 0.1667 of Mg, I'll get 0.1667 of H2. Oh, okay, so both cases the Mg same, H2 same. Oh, that's why I end at the same place. But H plus wise, H2SO4 got more. Then why does it matter? Because essentially, isn't this an acid matter reaction? And do you remember the definition? Isn't acid represented by H plus? If the very thing that represents acid double, wouldn't it be faster then? Cause concentration higher. That's why the graph is steeper lah. Like that one? Yeah lor, though this is the toughest part of the toughest. Yes. But you can be assured there's nothing worse I can even think of. Yeah, it's like that. Yep. Okay, yeah, so that is it lah, basically. So that's the end for speed of reaction. Then now we are moving to the next topic, which is the experimental technique. Huh? We can finish this in 5 minutes because it's something that these are things that we kind of went through in Sec 2, parts of this year. But they are technically in syllabus, so I have to go through it once. Okay, let's take a look. Yes, there's such a thing called SI unit. So this is a standard units, in common standard for different measurements. Yes, so in terms of mass, we use gram. Yeah, sure, kilogram is more for physics lah. 1 ton is 1000 kg. Do you need to memorize? Don't need. Because in the exam context, we will tell you that 1 ton is 1000 kg. So you can convert accordingly. 1 ton is not the noodle. 1 ton noodle. I'm joking. Yes. To measure mass, you can use a beam balance, which I don't think a lot of you have seen that before. The one that you usually see is electronic balance lah. Okay, time, SI unit is seconds. Other terms, minute, law, hour, cool. You use an analog stopwatch, you can use a digital stopwatch. But I'm sure at this day and age, you use a digital stopwatch. Analog stopwatch looks like an antique. So cute, right? Okay, next, temperature. Temperature, SI unit is Kelvin, but we often use degrees Celsius. This one doesn't really impact us that much because in O-level chemistry, we only use degrees Celsius. But if in any case you went to JC and you decided to take JC Chem, you learn that Kelvin is also commonly used in Chem. Physics, I'm pretty sure JC physics both need to use lah. Currently, secondary school physics, I don't really think you need to touch Kelvin much. Yup. So you don't even use a mercury thermometer anymore. You use a thermometer that looks something like that, but the chemical inside is, I think, thallium or something else. Yeah. Data logger. Actually, a data logger is very powerful equipment. You can use it to measure many things, even pH changes. So technically, you can do acid base without any indicator, without anything. Just stick it in this probe in, this data logger in. But then again, our aim is to train you to be able to do the experiment using the original OG apparatus. And if some of you next time become real lab technologists in a real lab outside, you will of course use all this high-tech equipment, of course. But think about it. Imagine you are doing some life-changing experiment project on cancer-saving drug or what, COVID drug or COVID 2.0 drug or something. Wow, you're so close to discovery. Then alamak, my machine spoiled. Then usually the alternative is do a simple titration, but I don't know how to do titration. In school, I don't care. Because normally got machine now. Oh, then imagine that hold you back, That's why you need to know your basic methods that you are learning now, what filtration, titration. Later on, they are more powerful equipment so that you know the basics in case things go wrong. Measuring volume. Volume commonly is cubic meter. Meter cube basically. But the more common one in chemistry is we love to give you in cm cube. We need to change it to dm cube. And just know that cm cube is ml, dm cube is L. You know that so much easier to change. And my teacher never tell me this. I'm not kidding. I had to do the mathematical way, which is gross. We can use things like measuring cylinder, burette, pipette. Yeah, basically. Yeah. Oh, normally we read a liquid, right? We read to the bottom of the meniscus. Only for things like mercury, you read the top. And also one more case that you may have experienced in the lab, your KMNO4. Remember that purple liquid that you have to titrate with? You find that, that liquid is so intensely colored. How to see the bottom? Yeah, so for those cases, like really cannot, no choice, you can look at the top lah. Yeah. I'll use the gas stream to measure gas. Lol. Okay, so you'll be learning 3 methods for collecting gases and 3 methods for drying gases. Because whatever you collect after a reaction, you want to be able to collect it, right? And you want it to be clean and pure and dry. If there is water, does it mean there's an extra chemical of H2O? Does it? Which means it's impure. That's how you learn the method of collecting a gas and drying the gas. Oh, cool. So, to know which method can be used, you need to know whether the gas is soluble in water. You also need to know whether the gas is the density of a gas compared to air. So let's take a look. First method. Downward displacement of water. As the diagram shows. Obviously, you cannot collect gases that are soluble in water. Because why? You want the gas to be collected. You want the gas to be collected here. So the gas will go into the water, then bubble, and go up. Imagine your gas is soluble. The gas go into the water, soluble, then it remain in the water. Nothing will be collected after that. Yep. It's okay. An analogy. Imagine me. I don't really like to swim in water. You push me into the slide. I go inside the water. Hey, water, yo. After climb, I go to the surface so I can be collected on top. But maybe someone else that loves water. Who loves water? Gabriel maybe. Whoever lah. Someone that loves water. He goes down the slide into the water. Yay, water! Then we just swimming around the water. You never collect it at the top. Something like that lah. That's the idea lah. Yep. Oh no. The second method is called the downward delivery of gas. Literally, you pump the gas in, it go down, and it sink. And why does it sink? It sink because it is very dense. Then, why is dense? So, the reference point is this. Air has a density of 28.8. Or you can think of it another way. The MR of air is 28.8. So when you find out the MR, when the MR is higher than 28.8, means it is denser lor. So for example, chlorine, Cl2, that's a 35.5 times 2, 71. Hydrogen chloride is 1 plus 35.5, 36.5. So as long as you're dealing with a gas that's very heavy, you can do downward delivery lor. And of course, if you have downward delivery, confirm got upward delivery, right? Yeah lor, same thing lor, upward delivery lor. Cool. Lol. Gas range. Then you don't panic. Do you need to memorize this table? Don't need lah. You more or less already could figure out most of them already. Okay, drying gases. You pass through one of these 3 drying agent. There's another English word that you may be similar. You may have seen before lah. It's called desiccant. Desiccant is also basically refer to things that dry things. And you see this quite often in real life. Why? It's those small white packet of things that you have in things that you buy lah. Maybe your shoe. When you buy a new pair of shoe, there's this small packet of thing that says do not eat. That one is actually to absorb the moisture. Or where else do you have those things? Maybe you buy some popcorn in a tin or something. Then you open up, you realize at the bottom got this white sachet of thing that says do not eat, do not give to a child or something. Yeah, those things contains a desiccant or basically a drying agent. It's meant to absorb any moisture that is there. And of course, you don't want moisture in your food, right? I mean, in those kind of food. Later the food spoil. So these three are the drying agent. So concentrated sulfuric acid. Two things. First, you want it to dry. Means it go in, you want it to come out. You don't want it to be inside. Yeah, so and notice this is an acid. So we cannot dry alkali gas opposite react what. It's almost like this imagine imagine okay imagine a girls' school, the classroom. I put one of you guys, I make you walk into the class and make you walk out of the class. You think that will happen? I don't think so lah. Because you walk in, you opposite to them then you react then you remain inside and you won't come out lor. So my drying fail lah. It's the idea lah. So you want to dry something, you want it to go in and come out. You don't want it to go in and react. So as concentrated sulfuric acid is an acid. You don't use it to react. You don't use it to dry alkali gas. Next, quicklime, which is calcium oxide. Calcium oxide is a base. Base. So you cannot use this. Cannot be used to dry acidic gases as I wrote down there below. Because why? Base, acid, opposite, react. And the last one is calcium chloride. Technically the best because calcium chloride is neutral. So you can dry everything. Because it doesn't react with anything. Neutral like Switzerland or Singapore, Yeah. And with that, we are done with the topic of measurement. Yeah. Next, we'll go on to separation and purification. So this is basically what I call separation technique. Some of these methods you are already familiar. Things like what? Filtration. We've done it in the lab many times. You know roughly how it works. Even crystallization. We've done it in the very first practical of the year. The blue crystal thing. These kind of things. So to do this now is just about officially going it through. So there are many ways, many things you need to know here. You know how to basically, if I give you unknown mixture, you need to be able to separate them. See, all these are about separating. So first, a pure substance literally means pure only got one thing, nothing else. Duh. Oh no. So a mixture means you have at least two things. And they are not chemically combined. You just anyhow whack, anyhow mix only So when we filtration is when you have a solution and a solid mixed together. And you can just filter. So the thing that goes through is called the filtrate. The solution that you collect at the end is the filtrate. The thing gets stuck behind is called the residue. Oh, so cool. Yup. Very simple thing that you already know. Yes, next. Next. Yep, we are done with that method. Next one is called evaporation to dryness and crystallization. They are actually pretty much very similar. Evaporation to dryness is technically for things that are stable to heat. That means you can literally heat it and go and drink coffee, go and pee, go and do whatever you want, then come back later. Oh, nothing will happen, nothing will decompose. You will just have the dry thing there lor. So most common example is your sodium chloride lor. Whereas crystallization is different. Crystallization is used for heat unstable substance. Which means things that will react in heat. Or another word that you may be more familiar, things will decompose. An example, sugar lor. When you heat, there's a difference when you just heat sugar directly. Your sugar will very fast turn black. But apparently if you can heat the sugar in some way, you can get caramel lah, get some very interesting thing, right? So yeah, crystallization and evaporation dryness difference. But good news, in O level, only NaCl should be evaporation lah. The rest you can go ahead and do crystallization. That's pretty safe. Yeah. So some of these heat unstable substances contain things like what sulfate ion, nitrate ion, carbonate ion. The ion, they are very big and complicated. They tend to break down because you're so big. When you heat you can break apart. So this just heat, the water gone, the thing left. Then sugar cannot because sugar is unstable. Sugar will become 超大. Sugar will become black thing. A soot, I think. Crystallization. So all these steps, right, you already done it in lab before. And also you probably try and memorize some parts of it in your salt preparation. So what happens? Very simple one. First, heat to saturation. Second, let it cool and crystallize. Third, filter to get crystal. Fourth, dry crystal between the pieces of filter paper. Done. These 4 steps are standard one. Heat to saturation, let it cool and crystallize. Then how do you collect the crystal? You don't use hand to pick it out, right? Technically you shouldn't do that because your hand may be dirty and everything. Filter. Yeah. Yep. This one is a little bit difficult, I guess lah. So they like to give you a mixture of 2 solid. They ask you how to separate them. Can come up with a few steps. So if that is the case, usually we think of a suitable solvent. I give you an example, it will be more obvious. So the example here is this. Sodium chloride, which is salt, and sand. So in real life, they both can look like solid lor. Like when you white color solid lor. I got 2 white color solid mixed together. How I know, sia? Yeah, so how do you separate them? So in this case, you will purposely add something like water. Because when you add water, sodium chloride, salt, dissolve. Sand, don't dissolve. Then after that, you can filter. Because at this point, you will have a sand. NaCl, AQ. You filter it. Oh, cool. Then what can you do next? You can evaporate to dryness. So in this case, you get NaCl solid. Yay! Then in this case, you will wash with water, distilled water. Then after that, you will dry lor. After you will dry. Yeah, so that's all. Next. Sublimation. Sublimation is used to separate a solid that's sublime. What is sublime? So sublime simply means this. Solid becomes a gas directly. No such thing as liquid. So normally is the solid melt become liquid. Liquid boil become gas. But in this case, don't have. And don't worry, there are only 3 substances you need to know in your syllabus that's sublime. First, iodine. Iodine sublime, you get I2 solid, I2G. CO2 solid, CO2G, and CO2 solid is your dry ice. And lastly, you have your ammonium chloride. The one I put a star there, that one is very special. It's like a classic. When I say classic, it's something that they comes out now on and off for exam one. So this solid you heat it become 2 gases. Yep. So literally you just take a filter funnel, you put the opposite, you take a wet cloth. It's essentially just providing a surface for it to cool down, basically. So you don't need complicated equipment, just a filter funnel and a wet cloth. Cooler surface, basically. Yup. Okay, so that's it for the first part. Second part will be on YouTube as well. So please, second part will be the second part of separation technique.